So when I was looking over today's lecture, I thought, dang, we already talked about that, okay? Because we did. Clear back in, when we started this class, we talked about identifying if a chemical reaction had occurred. Remember, we talked about chemical properties and physical properties. You did some of that in the lab. Chemical changes and physical changes. So we're going to kind of revisit that whole chemical change, chemical reaction thing. And remember we said, and you guys did an observation lab, you're like, well, I think a chemical reaction occurred because I saw new substances formed. Okay, that's what we're talking about. So chemical reactions, we're taking a closer look at them. And we can only talk about chemical reactions, well, it's going to help because we're actually going to write them out using what we call a chemical equation. Chemical reactions are represented by chemical equations. So I'll kind of put one up here to get the ball rolling. So a real common one would be, well, I've never done it, but actually you can take water and you can pass electricity through it, and you can make, and there's a big picture coming up. I think I showed you before, hydrogen gas and oxygen gas. Okay, so new substances are formed. Now, the thing about it is we still have hydrogen over here and oxygen, and we started with hydrogen and oxygen. Now, some of you who have kind of dabbled in this, you might say, yeah, but we have different numbers of different numbers of oxygens atoms up here. We'll kind of fix that here in a minute. But, bless you. The types of elements you start with are the types of elements you end with. The opposite of ordinary chemistry, I think I mentioned before, is nuclear chemistry, where you get different elements by either splitting the atom or fusing things together to make heavier atoms. All right. So this might be something, it just looks totally like a throwback from what we talked about before. How do you know you got new substances? Well, you could have a color change. You could have basically something going from a liquid to a solid. So here we have a liquid here and a liquid here. When they react, they form what we call a precipitate. Okay, new substances formed there. You could have a gas given off. We kind of saw some of that in the lab. In this case, we have two gases given off. New substances are formed. Sometimes chemical reactions will generate heat, okay, and sometimes they'll actually require heat. Sometimes chemical reaction will generate light. So keep in mind that when we say provides evidence of chemical reaction, that does not mean that it is absolute proof that a chemical reaction has occurred. I buy that. And that kind of gets back to, again, back to your one of your first labs, that observational lab. You can only kind of you guys made hypotheses as to whether a chemical reaction had occurred or not. And you guys came up with kind of follow-up things we could do to pin that down. All right, so this will be due on Marvelous Monday. And I'll kind of show you what you're up against here. It's very, what I say, descriptive. No calculator stuff yet here. And you might be like, well, what do we talk about so far? What questions could they ask? And so here's 1, 2, and 3. Again, 1 is the answers are in the back of your book. What is a chemical reaction? List some examples of chemical reactions. You guys can do that. If you could look at the atoms and molecules, what would you look for as evidence that a chemical reaction has occurred? New substances are formed. 3, what are main indications that a chemical reaction has occurred? See previous slide, okay?
I got the burnt marshmallow. I clicked on that one. I said it was physical, it was chemical.
Oh, well, yeah. Do you buy it now that it's a chemical, not a physical?
Yeah,
Okay.
yeah.
Okay. And then these are which is consistent with chemical reaction occurring and say why. New substances are new substances formed. So up here, when I wrote H2O liquid, electricity, over here H2 gas and O2 gas, this is a chemical equation. And they are read from left to right. Chemical equations are a nice, concise way of representing a chemical reaction. So on your test for your Unit 4 exam, I will ask you questions about the equation. And one of them, and you might already have this down, is that we call these reactants. I'll just put a letter R there. Anything over here we call reactants, and anything over here we call products. Reactants. And sometimes I'll say, kind of left from right, we say reactants goes to form, that's kind of the reaction arrow, products. And I'm not a word person. I took that whole left brain, right brain the other day, and I ended up with like 70-30, so I'm a little bit left, but I don't know, I'm a little bit right, but I'm mostly left, I guess. But anyway, what I like about equations is they say a lot with just a few letters, okay? I'm like, draw me a picture, give me a chemical equation, and then it'll be great. So there's 2 types of equations. This one up here actually is what we call unbalanced. Doesn't mean it's necessarily bad, okay? And your textbook would call this one a skeletal equation. So what's good about this? Well, like I said, in kind of a few letters, it just says basically this is called the electrolysis of water, okay? I'm breaking water down into hydrogen and oxygen, okay? Now, I'm going to go ahead and balance that. We'll be talking more about this on Monday, okay? I mentioned that if we look at just how do I say this, the number of hydrogen atoms and oxygen atoms, and actually this is kind of, I do a tally. Notice we have 2 hydrogens and 1 oxygen here. Oh. Over here on the product side, we got 2 and 2. Okay? Hydrogens match up, but the oxygens don't. Okay, so in order to fix that, and again, we'll be talking more about this in this Unit 4, we do what we call stoichiometric coefficients. So stoichiometric coefficients are big numbers to the left. I get my left and right mixed up. There are big numbers to the left of the compound. So notice if I put a 2 there in front of H2O, I need to update these guys. So now instead of 2 hydrogens, I have 4. Instead of 1 oxygen, I have 2. That work? All right, okay.
Now you need
So if I look over here then, now I have messed up I've messed them both up. Well, no, I haven't. Now my oxygens work. This is like my brick wall between reactants and products. Now my oxygens work, but my hydrogens don't. I can get my hydrogens to work now by putting a 2 there. 2, update, 4. Now my hydrogens work. So what I've done is put a big number, I'm emphasizing big, to the left, I'm emphasizing where it is, of the species, in this case, molecules, to make it balanced. Okay, that's balancing. And when I do these, I usually kind of draw a squiggly mark under the location of my stoichiometric coefficients. I think it's German, coefficients. What's the stoichiometric coefficient of oxygen? It is 1.
You don't have to put it there.
You don't have to put it there, but you can if you want. It's implied if it's not a number. So that's kind of a look at what we call balancing equations. But before we balance equations, let's look more at the skeletal equation, the unbalanced equation, and then we'll call it a day. So whether you balanced it or not, did you have a question?
No, go ahead.
Whether you balanced it or not, just the skeletal part, it tells you what we say qualitative information. Okay, so this is the skeletal part without the coefficients. Okay, it tells you the reactants and the products. Okay, and like this one showed something over, it may also show the physical phase. So like what's the physical phase of the water here?
Oh, the liquid.
Yep.
And then the gas.
Yep, that's it. Physical phases. And it may also show you anything kind of concisely that needs to be in place in order for the reaction to occur. In this case, it was electricity. Yep. So you're going to want to know these. S is solid, L is liquid, G is gas. And AQ means it's dissolved in water. So, for instance, let's see, you guys did sodium bicarbonate, NaHCO3AQ. Okay, now again, we just covered this, reading from right to left. This is my cation, and this is my polyatomic anion. So we talked about how Na, it's a 1A metal, it forms a +1 charge, and I would write AQ, I would show it running around in water. The other thing is hydrogen carbonate, or bicarbonate, same diff. So all AQ means is you have, if this is my beaker, here's my water, I basically have these things running around happily in there. Na plus and HCO3 minus. That's it. Okay. So I put electricity over the reaction arrow. Other things that might go over the reaction arrow is just heat in general. Sometimes chemical reactions, in order to go from reactants to products, don't just need any sort of heat. It needs a specific temperature condition. Biology is notorious for that. Okay, it could be a pH, dark, catalyst needed. Okay, so the stuff in red up here, this skeletal sort of information about the chemical reaction in this chemical equation, that's what we call qualitative information. Unfortunately, there's 2 Q's here. The other Q from qualitative is quantitative information. So quantitative information actually would be the balancing part. So that's quantitative. When we went ahead and put a 2 there, a 2 here, and left that a 1. Okay, we balanced it. That was quantitative information. So if it's unbalanced, it's awesome. It tells a great story. It's very important, but it doesn't give you what we say quantitative information. And these will also be due on Marvelous Monday. Take a quick look. All right. What is a chemical equation? Just do your best. I don't like reading things like that, but I will read yours, what you write. Give an example and identify reactants and products. Feel free to use your book, or you can use this one up here, and then just say, what does the G, L, S, and AQ mean? Okay? Good. So that's all. That's how far I want to get today. So let me know if you have any questions.